entire team will present the proposed design. Jeremiah AJ will be handling risk assessment. Rashad Brown will handle the schedule, and Jeremiah AJ will close us out with the budget estimate. And following that, we'll have any questions with the time remaining. Same group as last time. Just want to reiterate everybody's positions. Everett Ratliff, myself, project manager. Rashad Brown, secretary. Jeremiah AJ, treasurer. And lead engineer is Joel Ubudo. Our disciplines, myself, electrical engineer, Jeremiah AJ, electrical engineer, and Joel Ubudo, electrical engineer. Computer engineers, Rashad Brown and Joel Ubudo. Our group support, Dr. Frank, Dr. Zhang, and our sponsor, John Scar.
For future reference, you can probably not read everything on the slide, but just flash it up there briefly, and this is who we are.
Okay. Concept generation and selection of the project. We were presented with two designs, one being the TDR moisture sensor, and the other being an impact tester. The group chose to design the impact tester. A couple reasons for that decision. There are approximately 30 TDR moisture sensors on the market as of right now. There's only about 5 impact testers on the market. I feel like with such a high number of moisture sensors on the market, it's hard to take that design and up the ante of the efficiency of the design. With only 5 impact testers, we felt like we had a better chance of making a good contribution to the design to make it stand out in the market. The technology for the impact tester is a little less invasive than the TDR moisture sensor. We felt like we could spend less time reviewing the technology and more time as far as designing the impact tester. We'll be using a similar design to the device we have up here. It's the Plague Impact Tester of Terf-Tec International. As far as the physical dimensions, most likely will be the same. We will be implementing our own electronics to the device. We'll also be implementing a GPS module to the design so that we can store in the data for each test location and hopefully superimpose that onto a map of the field so that the user can view each test location along with the test result, time and date. Operating environment for the impact tester. Most playing surfaces, as we know, are outside. Some of the artificial turf surfaces are inside. I think it'd be a good estimation to say that the impact tester is predominantly going to be used outside. So it definitely needs to be sealed so that no electronics will be damaged in any kind of weather condition. It can be susceptible to rain, cold weather, hot weather. As we see here, we have a maintenance vehicle. It's a good chance that the impact tester will be used by maintenance crews. And with my experience in the industry, working with Southern Company, these kind of devices, when used by the maintenance personnel, it kind of possibly might get thrown into the truck with not a lot of consideration for the components. So it's definitely going to have to be shock resistant. Beef up the electronics so that nothing gets jarred loose with any kind of impact, whether it be the truck, other tools, it's tossed in the truck. They have heavy tools, so they can throw the other tools on top of it, shovels, hammers, the list is endless. So it's definitely going to have a rough environment, and we're going to have to build it to withstand all of that. Intended uses of the impact tester. Basically, the impact tester is going to be used to monitor the absorption of any playing surface. Playing surfaces range from tennis courts, golf courses, playgrounds, football fields, baseball fields. The list is endless. It can be used anywhere within the world for any sporting application. Intended users for the impact tester, as I stated, is primarily going to be maintenance crews, whoever's handling the upkeep of the playing surface. If it was any anybody else, it could be a privately owned field, but I still would only be predominantly used by maintenance crews. And now I'm turning it over to Joel Ibudo for project management.
I'm Joel Ibudo. I'm going to be talking about project management. For the project management, we distinguish two parts. Project management, this part is going to describe how the team will manage the project. It identifies the technical and administrative project managers, and it also describes how the team is going to work together to get the job done. So we distinguish two types, two parts, the project administrative part and the project technical part. In this part, the team decided and attributes position to the team members. So as Everett said before, he is the group manager, and we have treasurer, this is Jeremiah Adid, and secretary, that is Rashad, and I am the lead engineer. For the technical part, we as a group, we decided, we divided the parts where we look at what we will need to build the impact tester. So we found out that we're going to need at least 7 parts to deal with. So we then decided who's going to take care of each part. And for the accelerometer, it's going to be taken care of by Ratif Everett, and the data logger is going to be taken by me and Rashad, as well as the GPS. The LCD will also be taken by me and Rashad Brown. Battery power is going to be taken by Ali, Jeremiah. The download software is going to be taken by me and Rashad Brown. And the circuitry and casing is going to be taken care by the whole team. Okay, so how is the team thought about doing this task? We have 7 tasks. So the first one is the data logger. That is me and Rashad Brown who's going to take care of that. Well, what is the data logger? The data logger is an electrical device that is going to record the data. Why do we want to do that? Because we need the data to be stored so we can retrieve it anytime we want to do some calculation and then send it anywhere we want. How is the team thinking about doing this? By exploiting the interface of the data logger. For the data logger needs that we want to have, needs to have 2 types of interface, like an input and output interface. For the input interface, well, we divided these in 2 groups, like a subtask that we need to do with the data logger. The first one is storing data onto the data logger. How are we going to do that? Well, our objective is to make sure that the data that we are storing is the data that is actually sent. We don't want to make the mistake of having something stored that is not what we intended. So this is going to be our objective. And how are we going to do this? Well, we are going to have some specific data. For example, the GPS data that we have. And we are going to send this for storage. So we know the data that we sent in, and we are going to connect this to a computer for test verification and make sure that the data that we sent in is the data that is stored on the data logger. So the outcome of this is what is to be sure that the data that is inputted from the
Joel, let me interrupt you a second.
Yeah.
Have you guys already identified a data logger module or a optimal design of it?
Yes, we identified. It's coming later.
Okay, well, just as an organizational thing about the presentation, and this reflects the report as well, right? That you should present your design first and then go into details about how you're gonna do different types of testing, on it. Because without having seen your proposed design, it's harder to visualize exactly what you're talking about in this part. Also, I wouldn't spend too much time on this part. This is more for the report. So if you can just kind of quickly go through these slides.
Okay.
You don't need to read every word on them, just show us what the tasks are, okay? And then show us more of the design details.
Well, yeah, okay, the second subtask is the data retrieval, like exploiting the outputs of the data loader. And how are we going to do that? Same manner we send data to the data loader. That data that we already know about are going to be sent to the computer, to the LCD, and we have to make sure that that data that we know about is the one that we send out.
Yeah. I understand this is a general approach, and this is fairly obvious stuff, but it's important to like move on towards the specifics of particular parts you're using. I mean, it's great to have a general plan like this, but don't spend too much time on this, on the talking about it. Okay.
Well, we did the same thing with the accelerometer because this is the management, how the team is going to work out, how the team is going to use the accelerometer. That's why we did the work this way. I don't know if you understand what I'm trying to say, because that's the management, how the group is going to work out.
Yeah, I understand. It's just I don't mean to minimize the importance of project management, but we want to see the we know we need an accelerometer, and
because that's we divided the work in parts, and my part was the project management. I think the part that
you're also doing some engineering work too, right? So you're going to be presenting later on.
Yes,
in the presentation.
Yeah,
okay.
We're going to shot.
Okay.
Okay, focus. So we presented everything like how the team is going to work out.
Yeah, we can just skim through the task.
Yeah, let's just skim through this stuff.
Okay.
I'm glad you spent time thinking about how to manage all these, but let's just
Okay.
go on. Yeah,
This is on to our overall design, and we'll discuss the design of each component throughout this section.
Oh, can we look at that a second?
Sure.
Is that
Sure. We have a battery and charging circuit inputs, which will be powering the GPS module, data logger, microcontroller, and the LCD. We'll also be powering the accelerometer. Accelerometer will input values to the data logger. The GPS will also input values to the data logger. And
so I have a question. I mean, I don't know what data logger you're using, but can these input sources be fed directly into it, or do they have to go through the microcontroller first and then be stored?
Depending on the microcontroller that we purchase, it might have the GPS module already integrated within it. So I would say that's going to depend on the final decision.
Well, it also depends on the data logger's capabilities. I mean, the GPS is going to output a raw serial data stream, but you may not want to log the entire raw serial data stream. You may want to process it first, like only log the coordinates that actually correspond to measurements you made, right? Sort of thing. So you probably want to do some filtering in the microcontroller before you send that stuff out for storage.
Okay. And now we'll turn it over to Jeremiah for the battery and charging circuit.
Like Pete was saying, we divided each component, and I'm doing the battery and I have the job of finding the battery and the charging component for the device. Basically, like what I have here is like we need to find a battery that's fit inside of the specific board that we have, and then the battery has to be rechargeable, of course. And actually asked our sponsor in the American meeting, he said I think he said it was a 9-volt battery charging the old impact guess depending on which components we purchase, the microcontroller and GPS and all other devices, then we're gonna know the exact battery we need.
Question, John, did that 2 hours requirement come from you? Is that what did you estimate that, or was that something the team came up?
I'm not sure.
That's what the team came up with. Right.
Okay.
When it's off the charger, at least I'm guessing like they'll need it to be filled for at least 2 hours for testing.
Turned on for 2 hours, so the device should be able to be continuously on for 2 hours? Does that sound reasonable to you, John?
I think we did originally talk about maybe an auto
Yeah.
on-off.
He was talking about like if the device is not being used maybe for like maybe for 5 seconds or something, it will automatically shut down. So that's good.
So do you have a goal for like battery life? Like how often is too often to expect the customer to change the batteries, right? If they're under normal use.
Well, I think the rechargeable battery should be able to last, really for a whole day's worth of testing.
Right.
I would hope.
And then you plug it in and recharge.
Right, now, but I don't know how much continuous use that would be, I think it should turn off maybe after a minute or two.
Right.
Yeah.
And I don't think this will draw much power, so I think, it probably should be longer than that. But,
They're assuming like if it's on the whole time, that's what.
Yeah.
That's what. Oh yeah, I know. Like I was saying before, once we purchase the devices, then we'll know like what voltage the microcontroller is giving out or current, so we'll definitely know what type of battery we ultimately use for the device.
Okay, I'm in charge of the accelerometer. There are a lot of different measurements that accelerometers can make. The type of measurement that we will be doing is a shock measurement. This measurement is considered a near field measurement, and that correlates to the position of the accelerometer. The accelerometer is within 1 meter of the bottom of the device impacting the surface, so it's considered a near field shock measurement. For this application, there are 2 suitable accelerometers. One uses the application of piezoelectric field effect. This effect is a creation of charge due to a deformation of a crystal or ceramic within the accelerometer. As we see over here, picture on the bottom, this would be an example of a crystal or a ceramic. As the object becomes compressed by a mass on top, you see up here in this picture we have a mass compressing a crystal or a ceramic material, and this is the ceramic material. As the material becomes compressed, it generates a voltage. This voltage goes out. The raw signal of the voltage is just a charge with a very high impedance, which requires a very costly cable because of the fact that the cable would leak noise onto the signal as it comes to the microcontroller. If we didn't have the high-priced cable, it'd be very hard to actually see the signal itself due to all the noise from the cable.
How large is the signal again? You're saying it's hard to see above the noise. Is it just a few millivolts, or what's
The signal is going to be generated in 10 millivolts per gravity
10
experience.
millivolts per G?
So say we were detecting 200 Gs, we would be seeing 2 volts of the signal.
Well, that's not too
Yeah.
bad. Is that typical for these turf measurements, John? Do you know what the G max values typically are?
Anywhere from, I'd say about 40 to 120 Gs.
requirement of needing such a high price cable because the noise isn't such a factor with the low impedance signal. This can also be done by a charge amplifier. Those are, however, very costly, and within the last 10 years, most accelerometers have the ICP amplifier installed within the accelerometer instead of having to have a charge amplifier outside of the accelerometer. The second type of accelerometer is a piezo-resistive field effect. This is a change in resistance due to a deformation of a semiconductor. Instead of using a crystal or a ceramic, they use a semiconductor and they measure the variance in resistance. All of the accelerometers that we have looked at and are considering only utilize the piezoelectric field effect. And the accelerometer will have to be mounted to the device within the tube and will be fixed with a stud mount. There's different ways of attaching accelerometers to devices. In some instances, they're only glued, but since this is going to be seeing such a large impact with so much force, the only reasonable way to attach it would be through a stud, and that way the accelerometer can't move. If it was to move, it would definitely scatter the results.
Yeah.
So we don't want that to happen.
A stud, you mean like a bolt into the,
From what I've seen, you either have a bolt, you have a stud where you could screw the accelerometer down onto the bolt, or you have the accelerometer is equipped with a stud in which you could possibly weld a nut to a piece of metal and screw the accelerometer down. I think there's several options there. And this is just an example of one accelerometer that we're looking at. This has the ICP amplifier already inside of the device. Like I said, some of them don't. Some of them have the charge amplifier outside. Very, very costly. I think it's around $250 for the
Wow.
charge amplifier.
For
just
the
out,
external ones?
Just for the external ones.
You
And
definitely
if-
want it.
Yeah, and so if you think about it, you have a lot more connections to make too. You have a high price cable from the
Right.
accelerometer to the charging
This is
amplifier.
clearly much better condition.
Yes. And this is just one design in which the coax cable attachment is to the side. They also have, sir?
I was just saying, it looks pretty small, compact.
Yes.
I can't read the measurements there, no?
It's about 0.8 inches tall,
Okay.
and
It's very
I
compact.
think it's about 0.7 inches in width.
And how much was this one, or I guess you'll get the budget later?
We are gonna get to the budget. This particular one was $297.
$297.
So we're
Yeah, that's kind of,
we're in negotiations with the manufacturers, and now that we know exactly which accelerometer is needed, it really narrows down the,
John, you said you had a target for the electronics of under 250, I thought,
Under-
for the whole thing?
yes,
So that's clearly a problem, right? If that's-
yes, that's why we haven't
Gosh.
made a
So,
definite decision.
so you haven't found a cheaper class of accelerometers that would still do the job here?
Still looking. It seems to be over $200 for the ones I've seen.
Is it just because it's the high G-forces you wanna be able to measure?
Yes.
Compared to,
Yes.
the cheaper ones?
Yes, the cheaper ones are more like cell phone.
Few Gs
Yeah,
at most.
yeah. This is calculating, or is detecting a lot of G
A lot of force.
for the impact. So we're waiting to hear back from several manufacturers. We have per unit prices just for a prototype. We're waiting to see maybe if we can lower the price due to, say, their orders.
I could have sworn that, there was this little board I was looking at that had an integrated accelerometer, and it had a larger range, a pretty large range, although it might not have been as suitable for the shock,
Right.
impacts.
Right. I think most of those are integrated to, like, say, cell phones
Yeah.
or maybe a video game controller.
Let me send you, I'll try to find the information on the one I was looking at.
Okay. That'd be great.
Just in case it's suitable.
Okay. At this time, I'm gonna move on to Rashad Brown with the LCD.
That's great.
For the ALCD,
what's the new first line again?
Time of day.
Time of day, okay.
Well, those aren't in any particular order, that's just the, what.
I got you.
like you said.
Just need to tell.
For the GPS will be connected to the input of a FAMU controller. We will be looking for a GPS that has extremely fast TTFF time, which means that the GPS which is the measure of the GPS signal to the satellite. So and from the satellite to the position. So we would like a GPS that has a fast TTF time.
Time to first hit, so that's how long it takes to get the first reading.
In this particular GPS that we're looking at, the MGPN OPA60 is a PI GPS module, which means
That's not bad.
right. These reports it'll directly fit onto our particular microcontroller board. The dimensions is 16 by 16 by 6 millimeters, and it supports the NMEA 0183 data protocol, which is the National Marine Electronic Association. And under the standard protocols, they use like 25 different sentences, and the VGA is just a basic sentence that sends out a string of data, which already has the time, the latitude, and the longitude, and as the data gets sent to the microcontroller, we can probably program the longitude and latitude to get sent to this line of the LCD. The data gets sent to this line of the LCD, but evidently we have to find another type of sentence that has the date that's with it.
Yeah, I think GPRMC or something like that has a date also, or I can't remember now which one it was, but yeah, there's definitely one. Should have the date. Very good.
And this particular data log, it's not guaranteed that this data log will work, because we still waiting to hear back from the manufacturer about the specs of it. But it will be an output to the microcontroller, and our particular data log must be able to store at minimum 100 testing experiment, and it connects to a PC using a USB, and it also has an SD card inside of it for extra storage, and it's compatible with Windows, Mac, Linux, and its dimension is about 3.7 by 2.5 by 1.1 inches in weight one gram.
So I have a comment. I mean, I don't know how expensive these sort of off-the-shelf data loggers are, but if it turns out to be a significant part of your cost, or if you want to simplify things, I mean, you could probably do without the data logger and store the data internally in your own code, right? As long as you have a board with an SD card for it, then you could just directly write the data to the SD card, and then the person on the PC later can just stick that card in because you can buy these USB sticks that you can just plug an SD card into and read it directly on the PC. So
I mean, I think Jeremiah added that to his budget, that option. But one thing about this data log is it also has the Bluetooth capability, and I already had the GPS monitor in it. So just in case.
this one had a GPS.
Yeah, it already has the GPS.
Nothing has it.
You can pass it around, but we can't use it.
Oh, it's just not a suitable one. Yeah. Okay. Well, that's interesting. So this has almost everything you need to do the whole thing. Darn, just had that 120 G accelerometer. Well.
We did the work together. I don't know if you can allow me to go back and try to explain something.
Oh, sure.
Just on the charge.
Yeah, I just wanted to make sure I'd seen some of the engineering details there.
Yeah, right, yeah. actually, there's a mistake here. This part is here. I think we had a mistake on after the last tire. This one.
You're gonna do it the other way around, microcontroller
Yeah,
connects
this
to
here.
those.
And it's powered exactly as it looks, but we have data from this one and data from this one that we need to work on microcontroller before we can send it to the data logger.
Yeah.
And if the data logger is here,
So it's kind of backwards. And the data logger would have your connection, your USB or whatever.
get the USB, but yeah, the microcontroller will also send message
To the LCD, so-
not from the data logger, not from the data logger, but the microcontroller here.
Yeah, I understand.
Last
So,
one.
yeah. Okay. Well, just include an updated version of this in the next presentation. Okay.
Talk about risk assessment. We narrowed it down just in case like that, anything, during the time of project, something will go wrong, and like what the team will do in order to solve that problem. And the first thing, we talked about just in case a team member gets sick and like there's no like, you can't continue the project, or is out of school. We decided that, if, depending on how small, the project, what they were working on, somebody would volunteer to take on the project. If not, then this assignment will be distributed evenly with the whole team, and then then we take care of that problem. And then, as far as the technical problem of different components, we came up with a part, like whoever ordered that, component, will research, the problem with that, part, and if during his research and he couldn't find a specific solution, then the whole team will take on that problem. And if we can't find a specific problem, then I guess we'll go back to advisors and seek probably help. So, as far as this calculation of the budget, if by any way if we go over the budget given to us, then we'll discuss with our sponsor, John Moscato, tell him why we went over the budget, and if he's willing to add more money to help finish the project. As far as the errors with the source code, the two programs, Rashad and Jalal, will go over the code. If there's a problem, either there's a small problem with the code, they'll find ways to fix it. If they can't fix it, the whole team will try to come up with a better solution to try to fix the code. And as far as underestimating our requirements, assuming if we can't find, assuming we can't we didn't complete a specific part, or something happened to our project where we can't continue, then the whole team will have a group meeting, and we'll allocate more time to the project where we have to spend more time trying to fix that specific problem.
Okay. Schedule.
We had difficulty loading the schedule onto the slide, so Rashad's gonna pull up that.
Sure, I know it's hard to see the answer.
You are probably still probably can't read it as clear, but, as of now, I have included all the milestone and meetings, and we are scheduled to meet with Mr. John Moscato as of now.
Oh, okay, you got all the meetings in there.
Yeah.
Okay, that's good, but is this everything? Because you really want more detail than this on the actual engineering, tasks, right?
I mean, so far, I had to research on.
Ordering components. Is it, this is just the fall schedule.
Right.
Do you have spring also, or is that, can you scroll over, or did you not do that yet?
I mean, for the spring, I already inputted our milestone, but like from the end of November to Christmas break, we want to see how much programming we get done with each component to carry over.
Yeah, I mean, I understand, but you really want to set yourself some goals for, how much time you plan to spend on each part of the design. I mean, you should break down the programming into modules, the code modules, and try to spec out, we think we need to spend a week on this module, a week on this module, and so on. And just arrange them in time, figure out what order you're gonna do the coding, and, it's easy to underestimate how much time it's gonna take to actually program it and get it working, so you wanna spell out in as much detail as you can. I mean, like, there you have testing of each individual component, 12 days. I mean, there's several components there, it could take a week to test each one of them. You could do some of that in parallel, but put that as separate, we wanna see that as separate items in your chart, you know, at least from the grading perspective. We'd like to see you break it down in more detail than this. Budget next.
Well, we,
That's the goal, right?
that was the goal for the whole, entire project, so it could be, 250 or lower.
For the unit cost
For
in
the
large
unit
quantity,
cost.
right?
Yeah, yes. Alright, so this is the part, like, so far the parts, like, you've been looking at the microcontroller cost, that's the price of the microcontroller, accelerometer, GPS. Obviously, you see, like Pete said, we found an accelerometer, which is $297, and then, we're trying to still see, like, per unit cost, to order 100. And the data logger, we were thinking about, like you said, we trying to see for, add an SD card.
Oh, if you just do an SD card.
Yeah, which would be like $20, and the LCD $49, electronics, storage, batteries. Found a battery, but we're still not sure if we're gonna use that battery, but it was, expensive.
Chargers, $86 just for a battery charger?
It comes with a battery and the charger, so.
What kind of batteries are these again? I didn't see the batteries on the presentation.
I think I have it on,
You have a slide on that?
it's down there somewhere. What was this, AccuCell battery I seen, so it was pretty expensive.
I mean, cause you can get these, you know, little just nickel cadmium rechargeable batteries from Radio Shack or whatever, and then they have like a cheap module you can just, I mean, if you don't mind removing the batteries to charge them.
Yeah, that's.
If you wanna charge them in place, then.
Yeah, that's nothing, yeah.
That was, one thing that John specified perfectly.
Charge in
having
place.
Charging in place so the user won't have to pull it apart.
That would be more convenient. But look, there's all kinds of cheap products out there that are rechargeable. There's gotta be a cheaper solution than that, right?
Yes.
We're still researching,
I mean, I have a Coleman lantern from Walmart that was like $20 altogether, and it's got a recharger in it, right?
Right.
So, I'd maybe keep looking on that one.
This was like the per unit, assuming if we're to purchase, each one like 100, the microcontroller would be $23 from $28, and the GPS would go from $40 to $32, and, the LCD would go from $49 to $39.
Oh, for different quantities.
Yeah, like different quantities.
Yeah. Yeah, I mean, eventually probably you want a table that has quantities for the whole product,
Yeah.
right? And how much it's gonna cost for the total unit cost of all the parts, the bill of materials in those different quantities.
Yeah, the same thing. That was the data logger and the GPS all in one that came with the accelerometer. That obviously that price was expensive.
That was the separate standalone data.
Yeah, it was $190 and it's about $25.
What's this bottom thing? Apple, you said?
Yeah, that was the battery I was talking about.
Oh, that's a battery and charger.
That concludes the presentation, and we reserve this time for questions, although we normally handle questions throughout.
I know, I have a tendency to.
But we always like to keep it there just in case.
That's all right. John, do you have any feedback or concerns or, I don't know?
No, I mean, it sounds good. The accelerometer is gonna be, probably the most expensive part of the whole thing. And I think we know that. I think the data logger, it seems a little pricey, and the battery charger, I think those could be a lot, there's gotta be some stuff out there that's less expensive, because that's pretty common stuff. The accelerometer is not that common, so, there might only be a couple manufacturers or something.
That's what I found so far, it's kind of slim.
And, we'll just have to work around it, you know, that's the heart of this whole thing. So, you know, we'll just have to see what's available.
You already looked at the accelerometer that's in the flag?
I just gave him some information on that exact
We
unit
just-
that's
You had
inside
sent us a
there.
photo earlier, that was what that was, right? That
Yeah,
photo.
I think I did send you a link to that
Yes,
page, but I
that's-
just gave it to Everett too, that's the exact same unit that's in there. And the other thing is it's a top mounted coax cable as opposed to a side mounted, because there is a, you know, small amount of space in there, and having a side mounted cable can cause a problem.
As far as looking at the actual accelerometer, John mentioned he didn't really feel comfortable pulling apart the,
Oh, I see, yeah,
Bottom
since they're so hard to
apparatus,
get these units, you don't wanna destroy one and
Not yet.
take it apart.
When I get an extra one for sure in stock, I might, take it apart. I'm pretty good at putting things back together. Yeah, but that's my only real concern, you know, is the data logger price and the battery charger price. I'm pretty sure we can do better than that.
But I'm glad you researched the types of accelerometers, because that's good to know, because I didn't know what type was suitable necessarily.
if I would've had enough slides, I could have told you.
A lot more about it. So you're the expert now on the
I have
accelerometer.
pages and pages of handwritten notes.
Good. Now, that's what you wanna do, you know?
Yeah, well,
We're certainly not limited to the accelerometers that I've shown, but as far as, like I said, manufacturers are quite slim. And so, the piezoelectric field effect seems to be the most common used accelerometer for this type of application. So certainly continue to research that.
Okay. Yeah, see if you can get a discount, but. I mean, that price, the $297, that was already in quantity, or it was?
No, that's only a prototype cost,
Okay.
and I should be receiving an email momentarily from that manufacturer, so.
And you may wanna ask them, tell them this is being developed for a product, right? And so even if normally they don't give small quantities for a cheap price, they might be willing to do that, given that
Right.
it's a product development, it's not just us making a one-off,
Okay.
thing. So,
They won't write me
so
off.
they may be willing to come down on the price.
Okay.
And, if you tell them you're a student team doing this as a project, that may also give you an academic discount, so.
Right.
Keep that in
And
mind.
I always tell manufacturers when I'm talking to them, I tell them that this is an OEM use, we're gonna be using their component in one of the products we're gonna make, and they usually have a whole separate person that handles that. And, they'll usually work with you pretty well on pricing. Is this the United States,
This particular one was, yes.
Okay. And the other one is in UK, the one that I sent you, that I gave you information on too.
Yes, I have, attempted to contact them, and I'm waiting an email back from that company as well.
Okay.
Yeah, and if you need any help, getting a hold of these people, just let me know, and
Okay.
I'll be more than happy to help you, out with that part of it.
Okay.
Yeah, that sounds.
Yeah, by the way, for the next presentation, you wanna really have pinned down by then exactly what are the interfaces between all of these components, so.
Okay.
I wanna see how many wires there are, physically, what exact data format it is in each connection, what voltages all of the signals are at, So basically, you should completely understand all of these communication interfaces, all right, of all the components. I mean, it's okay that you didn't have that much detail in this presentation, since this is just, preliminary system level design, but by the next one, make sure you pin down all that, because you really have to know all that before you can even begin, the detailed, programming and wiring things up, so, make sure you present all those interfaces. Great. All right, thanks, guys.
We appreciate everybody.
Looks like progress.
Oh, and I told them also that, to let me know sometime next week when all four of them are available, and we'll take this out onto Florida State's.
Oh, great. And actually try it in the field so they can see how it goes. By the way,